Well, hello everyone, and welcome to our introductory video on Eagle. So in this video we're going to talk about the what, the why, the where, and the how behind Eagle. So what is Eagle? Well, most of you are probably thinking of a bird, and it is actually named after my favourite bird, so it's not an acronym for anything, but Eagle is an R package for genome-wide association mapping. Or another way of saying that, it's a tool for finding those interesting regions of the genome that house genes that are controlling a trait. But the way I really think about Eagle is an early warning tool for gene discovery. So Eagle's not going to give you the gene or genes, well in most cases it won't unless you're really fortunate, that are influencing a trait. But what it will do is it'll tell you which parts of the genome you need to pay attention to and which parts of the genome you can begin your search for those genes. Okay, so some of you are probably thinking, well, why do we even need Eagle? There's already a bunch of tools available to us to do genome-wide association mapping. Is this just more of the same? Well, let's look at the following motivating example. So here we have a very simple Manhattan plot in the sense that I'm not looking at an entire genome worth of data, I'm only looking at a chromosome. But there are some inherent problems in the way plots like this are generated. So first of all, each one of those points is measuring the strength of association between the SNP and the trait. But the way we do that is with a very simple genetic model. So the analysis itself is not simple. I'm not saying that because actually to generate, I'll just go back. So to generate that plot, the analysis is quite complicated. Each point has come from the analysis of a linear mixed model where we're measuring the strength of association between the SNP and the trait by including the SNP as a fixed effect in the model. So the analysis itself may be quite complicated, but the underlying genetic model is quite simple because we're only looking at the degree of association between a single SNP and trait at any one time. So with Eagle, what we do is we actually look at the association between all the SNPs and trait, and we do that simultaneously within our modelling framework. Another issue with standard approaches for analysing GWAS data is that we are treating it as a variable selection problem. So what I mean by that is, each SNP is a potential variable that we have to work out how important it is sitting within the model. But that creates some problems because what we have is a situation in most cases where the number of SNP we have or number of variables we have far outweigh the number of samples. So that causes some challenges, and the way we get around that using standard approaches is that we just look at the significance of each SNP in turn. But that causes some problems, and it's known as the multiple testing issue. So if we just had a single SNP, not that you ever would, but if we had a single SNP test, then as statisticians we have that covered really well. We can control the type 1 error really well in that case. But when we go this issue of actually doing multiple tests, and when those multiple tests are correlated, as they are in our case, because SNPs are correlated along the genome, that causes us some issues. So the way we get around that in Eagle is we don't think about it as a variable selection problem, we think about it as a model selection problem. And what that means is we're now released from having to deal with multiple testing issues. We don't have any multiple testing issues sitting within Eagle. One of the other issues with dealing with Manhattan plots is you have to come up with a threshold. So what you say the threshold is if points sit above the threshold, then you're going to believe that it's a true signal. If points below the threshold, then you're going to say it's just random noise. But what do you do in those situations where you have points that are very close to the threshold? Or what do you do in situations where you're collaborating with people and they have a different threshold they want to use and it gives slightly different results? So, in those situations where you have really strong signals, this is not an issue. Doesn't matter what threshold you use, you're going to find the truth. But it's talking more about those situations where it's grey. And I think a lot of the complex traits that we're dealing with now are fitting in this category where you have potential signals but you're not sure. So with Eagle, we don't deal with thresholds at all. Because we're treating this as a model selection problem and not a variable selection problem, there are no thresholds sitting within Eagle. So where can you download Eagle? Well, the first part of the process is to actually install a multi-threaded version of R. R by default only comes with single-threaded math libraries, but what we'd like you to do before you actually go and install Eagle itself is to install a multi-threaded version of R, because that way you're going to get the most out of Eagle. Uh, there's a couple of different ways in which you can do that. You can install Open Blast, which is like a multi-threaded Blast library. It's freely available, and you can then integrate that into your current version of R. Or the way that we prefer, and I think it's easier, especially if you're new to R, is that Microsoft have produced R Open, which is a freely available version of R. It looks very similar to R, except it actually comes with MKL Blast Pack libraries, so a multi-threaded engine, and that's fantastic. So, in terms of performance, it's night and day. Once you have R installed, it's very simple. Just start up your R session, and from your R session, all you need to do is go install packages, Eagle, and that will install Eagle along with any dependent packages that you may not have on your system, but it's required to run Eagle. In this last slide, I just want to talk about how Eagle is different to a lot of the other approaches that are sitting in this space for genome-wide association mapping. So first of all, in terms of methods, it is a multi-locus method. We do look at all the SNP trait associations fitted simultaneously, so that's a big difference compared to standard approaches that only look at the degree of association between a single SNP and trait. We are looking at this as a model selection problem as opposed to a variable selection problem, and the consequence of us doing that is we don't have to worry about significance levels or thresholds, and I see that being a big difference to standard approaches where you've got Manhattan plots and you do have to come up with some sort of threshold. One of the other issues is that there are multiple locus methods already sitting in the space, but most of those methods, part of implementing the method, you have to deal with this regularization parameter, and in Eagle we don't have that at all. In terms of implementation, we are calling it an R package, but that's a bit of a loose term in that R's like the top level, but most of the code's sitting in C++ land, and we've done that for performance reasons. One of the other things that Eagle can handle that a lot of the other packages in this space can't is that we can deal with data that's larger than the memory capacity of the machine. We're using multi-threaded computation throughout, and we have two modes of use because we realized that there's going to be a mix of users for Eagle. There's going to be those who are very comfortable in using R, and we're calling you guys old school. But we wanted to make Eagle accessible to people who are not familiar with R. So what we've done is we've actually developed a GUI to go along with R, and in that case, you actually only need a couple of commands, R commands, to get you going. So it's a very easy way of interacting with Eagle. So thanks for your time.